Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols.
Hey y'all! Well, time to jump back into the 12AX7 EL34 amp. Had a lot going on trying to get this business up and going. Been dealing with vendors, trying to get my tax exemption stuff all worked out with them. Also been trying to, get a good BOM together. The other thing that I ran into was, and thanks to you viewers, or one of you viewers that pointed this out, I'd forgotten that I made a typo in the power supply for the 6SQ7 EL34 power supply, and that was supposed to be a 270 UF cap, not a 470 UF cap. And somehow I had a 470 UF 450 volt cap, so I was like, yeah, that maybe was what I did. But then when I went back and simmed the power supply, I realized, no, that cap's way too big. And so I ordered some 500 volt 220 UF caps to use for the second cap of the power supply. So I'm going to show you, that. It's got the same outside diameter, so it should fit in the same clamp and, be a pretty much a bolt-in replacement. Feel like going with a 500 volt cap, even though we're not at that voltage level. It's going to give us some headroom so that the cap will have a nice long life. And also, I believe it's a 105 Celsius rated cap, where this was an 85, so that's a good thing. So in this video, we're going to be finishing up the power supply and getting the heater wiring done. And I figured out the tag strip layout and where all the components are going to go. And I don't know how deep I'm going to get into that in this video. We may touch on some of it. The main goal is to get the heater wiring done, get the power supply finished up, get the wiring to the output tubes so that we can power the amp up and check the milliamp draw on the output tubes, make sure that they're biased right, which I'm pretty sure they're going to be, and see where the B plus is. But since this is basically a clone of the 6SQ7 EL34 amp from the driver tube back, then it should perform the same way that amp did. And honestly, this 12AX7 is basically two 6SQ7 triode bottles in a single tube. So everything should be the same. So anyway, I'm excited to where this is going. Like I said in an earlier video, we're going to build a couple of prototypes. We may end up actually building 3. And we're going to do one with the EDCore iron, and we're going to do another one with the musical power supply iron. And given that they use the same end bills, I'll be able to A/B test them with other people. And Woody, the guy that I was working on his 300B, he's like, yeah, bring the amps over. We'll hook them up to my clip speakers, my Fortes, and you can just not tell me which one's which and ask me what I think they sound like. And I plan on doing the same thing with my friend Willie that we've done some listening tests with in the past, and not tell them which one's which, and just kind of be quiet and say, what did you hear? Which one sounds better to you? And because I really want to try to figure out which one of these output transformers we should use for this, what I'm going to call a basic build. Now, I have been in touch with Thermionic Labs. They're sending me a pair of their 20 watt 5K output transformers, and I'm thinking about doing this basic version that's going to have either an EDCore or musical power supplies, kind of the more budget-friendly output transformers, and then do a higher-end version that's going to have the Thermionic Labs or possibly the small ISO Tango 12-watt transformers. And we may end up doing, another prototype with those two to compare. And then on that version, have the triode ultralinear switch and also have the feedback loop adjustment on the deluxe version that's got the higher end iron. And so I'm kind of thinking that's where I'm going to go, is try to hit two different price points and use, a little better iron on the more expensive version and, a little extra features on it. Because this is going to take some extra wiring and stuff. And so to really hit this budget price point that I'm trying to do, which it's not super cheap, but to hit the price point that I'm aiming for the basic version, it's probably not going to have like a bunch of switches and extra wiring and all these other little features to be able to hit that price point. Anyway, let's get busy working on this power supply and try to get this thing ready for its first power up. Let's go over some of the wiring that we've done so far. We've got the high voltage AC off the transformer going to these two terminals on the rectifier tube. These are the 5-volt heaters for the rectifier. The high voltage DC comes off the rectifier tube here, and it goes over to the choke, comes out. This terminal is going to be the filtered high voltage DC. And then this terminal is connected to this terminal. This wire comes up here to the positive of this 220 UF 500 volt cap. And then here's the ground wire that's going over to our ground terminal, which I'll show you in a second. And this is the 510K bleeder resistor. So here's our power switch. These are the two switched AC wires that go back here to the transformer wiring. And then these are the LED wires for the illumination. So let me turn the amp around and show you what's going on this other end. So this is the ground wire from our capacitor. This is a 3-terminal tag strip that all 3 terminals are connected together with a piece of 14 gauge copper wire. We got the chassis grounded down here with a nut grounding this whole terminal strip to the chassis. So this is our star ground point. Here we have the safety ground on its own wire and lug over here by itself with a double nutted, with these keeps nuts with little star washers. This is sanded down too, so we've got a really solid earth connection for the safety ground. This is the fused connector of the IEC connector that goes up to the power switch that are these wires here. Then it comes back, goes to the transformer primary, and then this is the other hot transformer primary lead that's unfused that comes up here. So we have the switch on the fused side of the IEC connector. That's very important. We have the center tap for the high voltage AC coming over here to the ground. We have the center tap for the 6.3 volt heaters also coming over here to our ground point. We have this 22 UF film cap. The ground of it comes over here also to our star ground point, with the positive side hooked up to the positive DC off of the rectifier tube. Then over here we have the two 6.3 volt heater wires to go into these two terminals, and then we have a little bridge rectifier, a little 1 amp guy connected across the 6.3 volt winding. There's a small electrolytic cap here to filter this DC, and then the illuminator LED is connected up to this filtered DC. And I've said before, it's kind of overkill. You don't actually have to filter the DC, or I think you can even connect AC to an LED, but you're probably going to see some flicker, and it's not going to have the longest life that it could. So this is adding like 75 cents to the cost of the amp to provide filtered DC to the illuminator. And then I'm probably going to also be adding a drop-ring resistor on the positive leg of this. Right now I've just got it connected up, but I remembered I need to put a little drop-in resistor here to dim the illuminator down to a pleasant level. So then we have the 6.3 volt heaters. This comes down here, goes to the heaters on this output tube, and then it crosses over and goes to the heater on this output tube. And then we have the input tube heater wire comes down here, comes across the top of the amp. Let me see if I can show you what that looks like in here. It looks like that, and then it comes up and goes to the tube. And we're trying to keep this as far away from these other signal wires as we possibly can. And being over here, like up against the top of the chassis and then up here in this corner, helps shield it so we don't have any noise. So this strip here is our cathode resistor strip. And I found some, I don't know if you saw the last video, I bought these little China resistors and they were just junk. So I found some new old stock ones on eBay that look like this. And I got some of this high temp flat black paint so that you wouldn't really see them looking through the screen here. And I know somebody was commenting that, oh, if you put paint on them, it's going to retain the heat and all that. The insulating value of this paint is just almost nothing. And there's actually studies that say that putting black paint on something like this helps it radiate heat. So I'm not worried about that. And these are so oversized. I believe there's less than 2 watts of power being dissipated by these. And so having 10 watt ones, these are like super overkill. And being these larger 10 watt ones, it has a lot more surface area to dissipate the heat. So these are situated like right over the top of this little screen vent. Kind of hard to see underneath there, but it's one of these is over here. So the heat from these will be able to rise up and go up through the top of the chassis. This is going to be our 2 ground terminals. This is a piece of 14 gauge solid core wire. And I need to run another section of that up and over and up to our star ground point. And for a couple of these things, we're going to be using some super oversized wire, but hey, it doesn't hurt anything to, have a little extra gauge on wire, especially when you're going to be sharing a ground with a couple of tubes. So what we're going to be doing here is this cathode is going to hook up to this end of this resistor, and then this end will be connected to the ground. So the path will be like here through the resistor to ground. Then on this tube, it's going to come to this end of this resistor, go through the resistor, and then go to this ground. So the path on the other tube will go like that. And then we'll have one cathode bypass capacitor here, and we'll have another one down here. And it'll be nice and far away from these resistors, so we don't have to worry about the heat getting to the capacitors. I bought some nice Audio Note cathode bypass capacitors. The rest of these are, Nikon, that's a Solene, and then we're going to have a couple Audio Note on the cathode bypass. So that's going to take care of the cathode. Then here are the plate and the ultralinear tap wires. So that plate's going to go there. Then this ultralinear is going to go here. And we'll put our 1.2K screen stopper right here on the end of this wire with some heat shrink tubing. And then these two will be the same way. They'll come over to the plate like that. Then this will come over to the screen with a screen stopper. And that'll take care of the positive and the ground for the output tubes. And obviously we've hooked up our output transformer output leads up here to the speaker jacks. These two negatives will each have a wire coming over here to the star ground point to ground the negative terminals individually. Then the last thing we need to do before we power the amp up is we've got to reference the grid to ground. And so we're going to need to run a grid leak resistor. And I haven't decided exactly yet, but I think I'm going to go from here to here. Possibly going to go from here to here. Make this the ground. And then make this the grid stopper would go across here. I haven't decided yet how I'm going to do that, but that's going to be the next step, is deciding which one of these terminals on this strip is going to be the ground, and then running it up here to this
ground point tied together to ground. And then same thing on this tag strip up here to ground, whichever one of these I'm going to decide to use. And then we're going to have a resistor, I think it's 510K, that goes from this to ground to make sure that the grid is referenced to ground. Also on this tag strip is going to be the decoupling filter for the power supply going to the front end tube. And so there'll be a capacitor here with a resistor on each side. We're going to do them independently, left and right channel. I know a lot of amps combine the two channels through the same decoupling filter, but we're not doing that. I think it sounds better having each channel on their own decoupling filter for the front end so the channels are separated more. The other thing that we're doing that's a new thing for me is I'm not going to use this center tag on any of these strips for anything other than just mounting the tag strip down. That includes on this, or any of these, or this. The only one that's going to be grounded is going to be our star ground point. And what I'm doing is I'm taking a tag strip like this and I'm bending over this center terminal, coming in with some pliers and crimping it down like that. If you're new to the channel, this is the most hated tool on the channel. It's a dinosaur old channel locks, but I love them. Anyway, I'm going to bend that over like that and then come in and solder this together here for extra strength. And then none of these are going to be connected to ground to the chassis. Any ground points we'll have will all be floating. So that's a little something different we're doing this time. And I think it adds some strength to these tag strips. To bend that over like that, it's not just this little star thing that's holding the tag strip to the ground point. It's actually physically bent over like that too. So anyway, let me get to connecting some of these wires, get the cathodes hooked up, figure out how I'm going to do our grid leak resistor, and then we'll be ready to power this amp up. Okay, so we've got the output tubes all wired up now, and here's our ground wire, comes across over here to this center tag strip. Now remember, this has got a nice big ground wire that's going between these two tag strips here. So we've got a really good ground right here. Now the way these two cathode resistors are wired up, the cathode on this tube right here is connected to this pin. So then we have the cathode bypass capacitor going from this terminal to ground. This is the negative side of the cap. Then it goes through the resistor, and then it's got a jumper from this terminal to ground here, and that completes the ground path. On this tube, this is the cathode, and pins 1 and 8 are tied together on an EL34. They have to be. That's the suppressor grid and the cathode are tied together out externally. On a KT88, they're tied internally. Anyway, ground here goes to this terminal. So we have our cathode bypass capacitor that goes from here to ground. Then got the resistor. Then jumper from here to here. Then the ground return path is through this big fat wire to this terminal. And again, they all come back through this big fat wire up to here. The positives coming from over here. This is the output of the choke. So positive comes across over to here. And then these two terminals are tied together with this white wire, and that's supplying the high voltage DC to the output transformer. This comes over to the plate. It hooks up directly. Again, hooks up to the plate directly. This is our screen tap. It's going through a 1.2K resistor to the screen on both of the output tubes. And I have some heat shrink tubing here that I haven't put over this connection yet because I want to check the voltage across these screen stoppers and make sure that the screen current is within spec. I'm pretty sure it's going to be, but I just want to double check that. Then over here, we have this black wire. This is going to be our ground on this tag strip. So this comes over here, ties up to this ground point here. And then we did the same thing on this side. This is our ground terminal. This black wire comes around and connects to this ground terminal here. Then we have our 510K grid leak resistor that's going from the grid to ground, from grid to ground. So then I went ahead and put the grid stopper for the output tube. Again, it's 1.2K. It goes from here to this terminal, from here to this terminal. And this will be where the coupling cap from the plate of the driver tube connects, where the signal goes into the output tube. So we've got that all set up. So we're ready to power this thing up and see what the cathode voltage is and calculate up what the current on the tube is, make sure that we've got the right current going to the screen, make sure the plate voltage and the screen voltage both look good, and then we'll have the output tubes all wired up and we'll be ready to start working on the input tube. Okay, time to do some voltage testing. I pulled this up earlier on a Variac slowly to make sure everything was okay. We were all good there, so got it plugged into the wall outlet, and we're going to check some voltages. Have the ground hooked over here with this alligator clip so that we can probe these voltages using one hand. You always want to keep your other hand behind your back so that if you do something dumb and get shocked, it's not going to go through your heart. That's the key here. You don't want to be holding the chassis with one hand and probing with the other. So anyway, first I'm going to show you why I use tube rectifiers. And I see in the comments, why don't you just use a couple of diodes? It's cheaper. You know, you're wasting electricity and etc. using a tube rectifier. Well, let me show you why. So we're going to power up the amp. And as you can see, here comes the voltage. Ramps up nice and slow. Makes it easy on the output tubes, lets the heaters on the output tubes get caught up and get the tubes conducting before the voltage hits, and it avoids spikes hitting the capacitors and all of that sort of stuff. So next we're going to come in here and we're going to measure the plate voltage on both of our output tubes, and we're just going to call that 420, and then 419. We're just going to call it 420 as well. Well, let's just call it what it is exactly. We've got 418 there. Then we're going to check the screen. We got 413. And that's what I like seeing. Or 415, here it comes. I like seeing the screen just a few volts below the plate. And there's 419. 415. So, like I said, I like seeing the screens a few volts below the plate. So now we're going to come in here and check our cathode voltage. And for this one tube, that's basically 31 volts. And for our other tube, we have 30 volts. So if we do the math on both of the tubes, we are going to have approximately 60 milliamps. And I'll put up here on the screen exactly what that calculates up to. So let's measure the voltage difference across the screen resistor. We've got 413 versus 421. Can't calculate that in my head, but here it is on the screen. That's what we have for the screen current, and we should be fine there. And that's the output tubes all wired up and ready to go. Everything's right where I expected to see it, and this is a great place to wrap up this video. Well, I was glad to see that went just as we expected, and it's good to see the cathode voltage and the dissipation on the tubes and everything right where we thought it would be. So we're really getting close to getting this thing knocked out. And the next step is going to be wiring up the driver tube. Again, I'm really happy the way all these tag strips turned out. You know, I know that the way I'd done the grounding scheme in my other amps had not ever caused a problem, but there was some controversy about, yeah, you can't like use that ground point and just run wires. You need to have them insulated, whatever. And the way we were able to do this, where the only tag strip that is actually electrically connected to the chassis is this one way in the back here, which is our, star ground point, I think alleviates any concerns, that someone might have that this isn't a true star ground. And this will be absolutely a pure, true star ground amplifier. So, anyway, like I said, I'm excited that we're getting this close. Got some parts ordered to do the next prototype, which is going to be identical to this, but just using the musical power supply, output transformers. Pretty soon we're going to have the input tube wired up, have this thing finished up. We're going to be running it on the audio analyzer suite on the Analog Discovery 2, kind of running it through its paces, see what the frequency response is and the actual power output, the THD versus power, see where all that comes in at. Got gobs of different tubes that can roll into this amp. And I've already figured out there's a couple of different input tubes that we can use that would have lower gain if that's what you're looking for, especially if you're going to be running a preamp. And then there's just all kinds of different output tubes that can be used. You can use EL34s, you can use 6CA7s, you can use KT77s, you can use KT66s. Anything that's one of these 25 watt dissipation 8-pin tubes that has this pin out can be dropped into this amp and just see what they sound like. And I know they sound different. And so you can tune what this amp sounds like with your speakers by like changing the EL34s for KT77s, because they sound totally different. And there's probably some other tubes that we'll investigate that can be dropped in here, but I think that's one of the really great things about this amp is going to be there's a zillion different output tubes that can be put into these sockets that will tune the amp to what sounds good to you. So, hope you're enjoying this content. Hope you're enjoying my channel. If you are, please subscribe. Please like the video. Thanks to all you Patreon folks. Thanks to all you viewers that watch my videos. Really helps keep this channel going. Thanks to all you folks that have given me the encouragement to build this amp to put on the market and to actually create a business of skunky designs. So, excited for 2024. Thanks to you folks for donations and just everything y'all have done to help support the channel and my business. And until the next video, have a nice day.